A couple of DerbyCons ago, there was like the speakers, the mics were hot before the talk, so you had to kind of watch what you said before. So, we'll get started in just another minute. People are still filing in.
I prefer to this than
All right, sweet. Thank you very much. Okay, coming at you. All right. Okay, so we'll go ahead and get going then. So thanks again for coming out or watching online for those who are watching later. My name's Casey Smith. I'm on Twitter sometimes at @subT. So I've moved a lot of my code for the talk to Malwaria Labs. It's just a place I've created to put different proof of concepts and things to kind of consolidate some of my code. So all of the slides and code will be there that I'm demonstrating today. So what we're going to talk about today is .NET manifests and influencing the common language runtime loader. We'll look at a couple of things, but I want to take you through real quick an outline. We're going to look at sort of why this is interesting and some background on CLR. I realize not everybody may be familiar with .NET common language runtime, so just a brief overview. What manifests are, why they're important to developers and software deployment. An older technology, Windows side-by-side, that's still in use today on endpoints. Fusion logging, some of you may have heard of this before, but it's a way to really inspect telemetry around any time a .NET assembly loads, whether it's through a byte array or from disk. So there's some really rich data sets in there. We'll then talk about ways to influence or encourage the .NET runtime to run things that maybe it wasn't designed to run or didn't want to run. So things like profilers, application domain managers, specifically a class called activation context. And hopefully I'll put all this together with a tool based on a tool called Dynamic Wrapper X, which was intriguing to me years ago and finally was able to re-implement it in a new way. So, and hopefully explain my thought process and have time for questions. If we do not have time for questions, I'll hang out afterwards. And then lots of references and resources really to point you to the places where you can learn more or dive deeper, because certainly these are just things that I've looked at or been curious about. Okay, so I really like this quote. It came out in a blog on Google Project Zero a couple weeks ago, and just says, sometimes hacking is someone spending more time on something than anyone else might reasonably expect. And so I resonate with that because oftentimes I just spend a lot of time reading MSDN, looking at like traces from different tools, developer tools, just trying to understand what they do. And so that's a really fun way to learn, I think, is just ask lots of really good questions. And there's three things I want you to learn today, like what I think is interesting around .NET manifests and loaders. So first of all, we're going to be able to load any DLL we want from any location with VB or JScript. So definitely an older thing, but still interesting because sometimes VB or JScript is a sort of a gateway or a trampoline into something else. And lots of things run that. And then we'll look at how would I create a custom .NET object and then use manifest to load that into like a script host. So if I wanted to create like a custom method method or property, and I'd be able to do that pretty easily. And then lastly, how would I actually encourage the loader to run anything that I may feed it, if you will, on the endpoint. So sorry, just checking my timer here. Okay. So first of all, .NET CLR, Common Language Runtime, think of an assembly as a unit of deployment. They can be either EXEs or DLLs. The Common Language Runtime is an amazing testimony to software engineering. This is a really cool way of abstracting processors so you can run code on different operating systems. And there's a really rich set of telemetry around this thing. So when you start looking at the CLR, you're really looking at a very complex system that has lots of really neat ways to get access to data. And that's interesting, I think, for both offense and defense. Specifically, though, with loading and related to manifest, we're going to focus on two early stage elements. So what we call binding and probing, which is really how does the runtime know where to find an assembly and that you can tell it where to go look or encourage it to look certain places. So what does a manifest do when you're looking at .NET? You have to ask yourself when you're looking at a particular technology, why is this a thing? And often it's for developers that think of the problems they're trying to solve or work on when they deploy software. And so you have to really start thinking like a software engineer, what problems do they have? Deploying software at scale, maintaining software, updating, fixing things. So there's a lot of things in these frameworks that are used for those type of roles. Why is this even a thing? And there's a lot of really good documentation. A lot of time is spent when you're researching some of these things, just reading documentations and just asking, what does that property do? Or how would I change that property? Or how would I make it point somewhere else, whatever you might be looking at. And then specifically, there's things around .NET and side-by-side resolution that they help make sure that you ultimately, how do I find the right assembly to load or right DLL to load? If I was on version 2 and I've updated to version 2.01 and I want to make sure all my clients get the right version, that's really the problem a manifest, one of the problems I would say a manifest would be trying to solve. So encouraging the application to find the correct libraries, correct versions, etc. So how many of you have heard of SXS or side-by-side loading? Okay, so this is actually an older technology. It's really, you may have heard of DLL hell, where it's I can't find the DLL, or there's multiple versions, and making sure we get the right one. So this was side-by-side registration is a thing that helps with registration-free COM. So normally when you want to create a COM object, you have to put that into the registry and leave sort of an imprint there. And so there's a really good tool built in if you start digging into side-by-side. XS trace is an ETL or ETW component that writes ETL files and looks at hey, my manifest didn't work or my DLL didn't load, what happened? So think of it like a flight recorder. You turn it on, you run your tool, it records what happened, and then you stop it and analyze the trace output. So it's very helpful. A really good blog post I've referenced here talks about all the different elements of when side-by-side. So that's one area that we're going to look at later that will come up, is these side-by-side trace and assembly manifests. So what about assembly loading? So how many of you have heard of fusion logging? Some of you may have heard of this, a couple hands, so good, okay. So hopefully this is new to you. So when a developer is troubleshooting, why is my assembly not loading, or did I get an error, or it couldn't find the assembly, you can turn on fusion logging and it will record elements where was it looking, what error did it receive, access denied or file not found. There's a number of different elements that might help you learn why did that assembly not load. So I've put a screenshot here of some of the registry keys you can set to turn this on. This is again very, very useful for both research for offense and defensive capability. So you just set a path and you would run your fusion log. And then another reference to Matt Warren's blog. Matt is a .NET. He writes a lot about .NET and a lot of its performance and really low-level stuff. So there's a really good blog that describes some of the steps in assembly binding and logging in his blog called 68 Things the CLR Does Before Executing a Single Line of Code. It's a really good reference to dig into. So what does a fusion log look like? And so when I approach research and I'm looking at maybe loading a DLL in a weird way, or maybe using a tool in a different way, I just start asking questions. So I turn on fusion logging, and so here's an output of the log, and I just started asking myself, I don't know, what's app-based? How do you set that? It automatically got set to system 32, but is that, what caused that to get set, what's dynamic base, there's the application name. And if you look down further in the log, you can see, well, it was trying to find this assembly in the tasks directory, and it looks a lot like a URL. Maybe I could load from a remote location too. So those are some of the things, like when I look at an output inside of there, I might be exploring. So, okay, so that's a little bit about like some of the manifests and components, like things that influence the loader. Now, kind of shifting gears would be like, if I'm going to either instrument to collect additional telemetry or debug or investigate something, or inject something from an offensive perspective, what are some things I can use in the .NET framework to do that? So a couple of that are really interesting ones would be like profilers. And I referenced a blog here that talks a lot about a .NET profiler. So there's an environment variable you can set. So when any .NET application starts, either globally or per process or per user, it'll say, do I have a profiler set? If I do, go ahead and load that DLL. So that gives you really early entry point into a .NET application running. A couple of other manifest areas that are good are application and machine configs. And so these are typically in the location where the binary is. Sometimes you'll see attackers copy like system files to writable locations, and they often do that so they can put configs there or other files. So when you see people moving things around, it's because maybe they couldn't write to system32 to put a .config file there, but if they write it to C tools, then they could put the binary in a config and it'll find it locally. So that's kind of an interesting thing to be able to observe, like people shuttling system files around. Specifically, there's a really neat entry in the XML around the developer path. And so it would clearly states on MSDN, don't use this in production. This is really for troubleshooting, but of course attackers aren't going to maybe acknowledge that. So like dev path, maybe dev path is a really neat way to influence where the .NET runtime finds an assembly from. And then Amanda wrote a really good paper on hijacking .NET to defend PowerShell. It's a really good resource in terms of some of what I'm talking about here inside of that paper, specifically around like understanding PowerShell. Some of that was written earlier before some of the logging capabilities were available, but it's a really good read to look at some not only PowerShell, but .NET internals. So today, specifically just for sake of time, I wanted to focus on two areas, really the application domain manager. So some of you may have heard of these before. Some of this may be new. And so this is really interesting because an app domain manager, an application domain is a unit of isolation you could think of inside of a .NET application. So there are application domains that are set up by the CLR when an assembly is loaded or process is begun. And these can be controlled by environment variables. And then once you load your app domain manager, you can then further affect assembly resolution. So you can set up functions, you can override functions so that when a particular DLL is searched for, it uses your path or your recommendation as opposed to maybe what was expected by the system. So the interesting thing here is these can be set per process. Environment variables is what I'm referring to here, or user or system. So it could be actually a persistence mechanism. If you wanted to hijack globally every .NET application and put your like app domain manager there, you could easily do that. And we'll see an example of that later on in the talk. Oh yeah, there's another one kind of related to .NET, JS Profiler. Some of you may have heard of this. If you like JavaScript and like debugging JavaScript, there's this really cool environment variable called JS Profiler that will load anytime a script host starts. So that's also interesting, especially like if you're maybe doing dynamic analysis or you want to collect some data about a script. So, but also interesting if you wanted to inject a script into or a DLL into any script that ran. And so I encourage you to go look at some of these. There are a lot of environment variables that influence the loading. I've talked about a couple app domain managers, and you can look at the GitHub repo for the .NET framework and see a lot of these yourself and see, like, ask yourself, like, what would that actually do? Okay, so let's like bring it to a practical step. So in 2017, James Forshaw did a really good talk on .NET interop, and he describes this activation context class. Let me give you a little bit of background on why this was interesting to me. Dynamic wrapper X is this really interesting DLL that extends the script host, I guess is a nice way to say it. It lets you map API calls directly through VBScript or JScript. Now, why is that interesting? Because normally you can't just call load library directly from a VBScript or JScript file. So for example, if you look at the bottom here, we can create a dynamic wrapper class, and we could say create or register the message box function, which would be in user 32. We define the inputs, the return values, and now we can just make a direct API call. Now that's pretty cool. It's a DLL on disk, and if you go look at the documentation for dynamic wrapper X, it kind of makes sense, the early phases, but then there's actually registering just raw hex bytes that you can call. You start thinking like, I'm not sure a lot of COM developers need to like register, assembly code or functions, but you can use your interpretation of that. So pretty cool. How many of you have heard of dynamic wrapper X? I think I've talked a little bit about it before, but it's very good to be aware of. So Coadic is a really cool framework that Sean wrote, zero sum, 0x0, and this is an example of loading or setting up like the API calls that would be interesting to maybe offensive teams. So you have like virtual alloc, write, process memory, create thread. And so now I can do the entire shellcode run or Mimikatz, whatever I want to do, right inside of a JScript file. So that's really interesting. And so what I want to show you now is a really easy way to just load a DLL into a JavaScript file. So all you would do is set the TMP variable. So when you look at this activation context class, the location of the binary is really, it's going to go look in TMP. So by default, that's like user app data local. Okay, and so anything loading or running from there is probably suspect. I know that may be a little bit hard to see, but that's in the manifest text. That's just the name of the DLL. So it says message box 64. Here is the path that I set up. Notice I'm setting an environment variable to the process, and you could change that to user. If you do change it to user, that persists on a reboot, and that's nice. And then there's also system. You'd have to have admin to change that as well. So now I say, instead of my temp for this process pointing to app data local, go point into my documents for this message box DLL. I created a thing called dynamic wrapper X that doesn't really actually have to be in the DLL. What you're looking for here is like just load up a DLL and call DLL main. So just that initialization function. So, and then that has to match line 10. Whatever you created your class here, I just used the same structure. Pretty straightforward. All the other stuff is actually arbitrary, like the GUID and some of these other things, like they don't really matter. And if you're just trying to get like VBScript to load your binary and take off from there. So this is what it might look like. So here's just the code snippet at the top. You can see like here I'm just running this inside of a debugger, and I just ran like set a breakpoint anytime the message box 64 DLL loads. And so here you can see a very simple output showing that I just ran load library, and then I was able to see the DLL loaded. So that's kind of a neat primitive, kind of interesting, maybe useful, maybe not. A little bit older technology, but I thought it was interesting because that really means like I can run any DLL from any location anywhere. So let's do a demo. So essentially, if I type out the let's do load library. So in here, I know that's a little bit hard to see, but essentially I've just got my manifest in the JScript file. I've got the location. I then point the manifest, set the property, create the dynamic wrapper X. And so now if I just do cscript load library, it loads my DLL. That's from the DLL main function. So that's kind of, like I said, a neat way. It may just be that entry point that attackers are looking for. So you may find that curious. Okay. So observation, again, we created the manifest. We set the temp variable, created the object, set the property to the path for the manifest, and then we're able to load our binary. It doesn't really evade anything like in terms of like a whitelist or something like that. Hopefully you've got DLL whitelisting, but just it's still interesting. So now I wanted to extend this. So I wanted to be able to load it, any .NET assembly into JScript or VBScript. So now I wanted to build my own assembly that had methods and properties that I could call, just like dynamic wrapper X might let me do. And then I wanted to be able to do that for any system32 variable. So if you're familiar with .NET to JScript, this is a similar approach. It's just that you're loading it from disk instead of deserializing an assembly. And we'll talk about some of the risks of that in a moment. But for reference, define p-invoke method is a really cool component in .NET that lets you dynamically define those API calls that you may want to use, like you saw dynamic rep-or-x using. I'm really just putting this in for reference. There's a lot there, but when you start using these type of reflection and building different components, it gets a little bit confusing, like what is what and what are the steps. So hopefully that might help you organize your thinking around, like the app domain is the beginning, then it loads the assembly, then modules have the different elements under there. So I won't leave that up for too long, just for reference. Okay, so it's interesting because cscript is in System32 directory. I don't have write access to System32, or do I? And so how would I force cscript to find my assembly? Well, we're going to use activation context to do that. So it turns out, if you look at the documentation, that System32 tasks is a read-write folder for any user. And that's, you can explore the different reasons and permissions, but that's interesting because if you have a binary in System32, and you tell it to load this app domain manager or assembly, it will go look in the folder name that was related to the app assembly name that it's looking for. So like you couldn't write to System32, but turns out if you name your assembly tasks and put it in the tasks folder, resolution happens just fine naturally. So that's for defenders, you probably want to watch for DLLs loading from System32 task directory. It's probably unusual. Just some code for reference. These are some of the classes I wanted to create and methods. Pretty straightforward stuff. Here's the code. You would essentially set your manifest, and then you would say, create an object now called myDLL operations, which is going to be referenced from the manifest. And notice you're using the AX object that you created here. And now I can call any function like, get value, trigger the assembly. Now I've written an assembly to System32 tasks and I've loaded it through JScript, and I can call my own methods and properties. So that's exciting to me. Not as exciting as .NET to JScript, but still a cool way to extend the script host. So, okay, we're closing in on time, so let me just go a little bit quicker. So it does require a DLL on disk. It only affects cscript. Could we load, the question might be, could we load a .NET assembly into other .NET binaries? The answer is yes. But first, a word on single file bias. So very often, as defenders or researchers, we look at a single binary or single process in isolation, when in reality, these are complex systems with different parts. And so one of the things you may want to do is, even though you put something down on disk, it may just be a very minimal gadget that needs extra capability fed to it through a script file or config file. So once you start breaking things into multiple elements, that's a really hard thing. Like, it's harder to upload like 12 files to VirusTotal and get them to be analyzed all at the same time, as an example. So in summary, keep your gadget small, encrypt anything that touches disk, and it may help evade or slow down reverse engineering. So the question you may have is like, what are the System32.NET binaries? I used Matt Graber's PowerShell Arsenal to search and see like what are the things that are referencing the .NET framework. Matt had a really good tweet that basically said you can also use reflection load to determine the same thing. And also, Paul had a really good blog that defines a lot of what I'm describing here. And I know we're kind of going through this quick, but he did a really good job of looking at app domains and looking at persistence. So these are the binaries that will load .NET assemblies. So the steps would be simply copy your task DLL into that folder, change a few environment variables, and now you can load up your assembly. So let's look at the code. It's just simply an app domain manager inherits from the app domain class. Like I said, all this is going to be on GitHub. This is what the JScript file would look like to load it. And let's load Mimikatz into something new that no one's ever seen before, because that's fun. It's the last DerbyCon. So I'm going to load Mimikatz into this ts.wpf wrp.exe, because why not? If you look at the demo file, we can see I've got, I think I did cat instead of type, which was affected by my... So the demo.bat just sets two environment variables, app domain manager, location, and then the task folder. I've already copied it into the folder, so just so there's no magic there. We're going to go ahead and run the tool. You can see here, if I do task manager, and look at the details, there's not a process named Mimikatz. You can actually just see that we're running in the new file down here. So pretty cool cool way to load assemblies. And so I think I'm close to out of time. So I'm going to stop. Closing thoughts, I'll just leave it with this. Thank you. I'll jump through real quick to the last slide where the references are. Thank you for your time.